Welcome to Module 10, Lesson 1, Modeling and Writing Expressions. Today we're going to talk about how to identify parts of an expression, writing expressions with operations and variables, and how to use variables to represent numbers, understanding that a variable represents an unknown number, and write expressions using variables when solving a real-world or mathematical problem. All right, so we've talked a little bit about expressions when we talked about order of operations. Now we're really going to focus on translating those words into expressions and vice versa. So we've worked on how to solve the order of operations and focusing on numerical expressions. Now we're going to focus on algebraic expressions and going back and forth between words and numbers. All right, so here we go. So one of the first things we need to know is that there are a lot of different words that can be used in math. And some of the words here are given for us, like addition, words like added to, plus, sum, more than. Those are all words that we use to imply that addition is being used. Now we have to remember sum does not mean add. Sum means the answer to an addition problem. But if I said I'm looking for the sum of 2 and 3, that implies that I have to add 2 and 3 to find the sum. All right, so we have this list here of words that are kind of our starters here. Later on, we are going to talk about more words. Later on in class, we're going to start brainstorming more words because throughout life, you're going to have a lot of different words that are going to be thrown your way, and you have to know what to do with them. All right, so for example one, what we're going to do is we're going to take a look at these phrases, and we are going to create an expression based on the phrase. So first and foremost, we're going to do our ride, and it says the sum of 7 and x. So let's find that important word here, and we have the word sum. So sum tells us that we need to add. So sum means add. So sum of 7 and x. So sum means 7 and x are being added together. There is no change in the order of the number because sum implies that 7 and x are just being added. Quotient. Quotient means the answer to a division problem. So quotient tells us that the operation being used here is division. So the quotient of z and 3. Quotient also tells us that we can keep the order of our variable and our number, and we are doing z divided by 3. Now another way that this can be written is z over 3. And we need to get used to seeing expressions written in this way because in math and throughout your career in math, you are going to see division written in the form of a fraction. All right, for B, we're actually going to change gears here, and you are going to write a phrase for the expression. So here, when I have a number and a variable connected, so I have a coefficient, so remember, the number, so 11 is what we call a coefficient, because we are working on identifying those parts, and x, in this case, is the variable. When we have a variable and a number together, they're being multiplied, which is what makes the 11 a coefficient. So since they're being multiplied, I can use any of these words here. And I, in this case, am going to use product. So since I'm using product, I can keep my numbers in that same order, and I can say the product of 11 and y. So the product of 11 and y. All right, and then for B, the second one in B, I'm actually going to, since it's subtraction, we really like to just stick with minus, subtract, this and that. I want us to get used to using less than and subtracted from. So I'm really going to push us in this module and in this lesson to use the words like less than and more than because we're uncomfortable and unfamiliar with them and we have to get used to them. So I'm going to use less than in this case. So less than. So here, I can't say, so what kids like to do is they like to say, I have 8 less than y. Because they like to we like to write it in the order that we see it. But that's not the case, because you're saying I have 8 less than y. So what you're saying is that you have y and you have 8 less than that. So you have y and you're taking 8 away. But that's not what this problem is saying. This problem is saying that you have 8 and you're taking y away. So actually what's happening is you have y less than 8. Anytime you use less than or see less than, that should imply to you that your numbers are actually flipped when it's written in math. So I'm going to use math when we write it with numbers and symbols, and I'm going to use words when we write it in, well, words. Okay, so again, less than when it's written in words should imply that when you write it in math that your numbers are flipped. All right, so what I'd like you to do is I'd like you to take a moment and I'd like you to try these on your own. Now listen, because I want you, on this one, I want you to please use, for number 6, I actually want you to use more than or added to for number 6. All right, challenge yourselves. All right, so go ahead and pause, and then when you come back, we'll check your answers. All right, so you should have had 7n, and you could have had a multiplication sign in between here. That's fine, but let's try to get away from that. 4 minus y, this would have stayed in that order because it's 4 minus the y, so you are taking the y away from the 4. 13 added to x. The order does matter here because you're adding to the x. So you're starting with x and then you're adding 13 to that. So you have to have the x first and then add the 13. Here you could have the quotient of x and 12 or x divided by 12. If you have something else, we can check it in class. 10 multiplied by y, y times 10, the product of 10 and y. If you have something else, we can check it in class. Here you could have 3 added to c because you're adding 3 to the c, not the other way around. Or you could have 3 more than c. Because again, you're starting with c and you're getting 3 more than what you started with. All right, these bar models can get a little complicated. So I want you to take your time in going through this with me and listen carefully. All right, so to start off, what you need to understand is that rectangles represent the whole thing and the variable. Squares represent individual pieces. All right, so the first thing that I am going to draw, and I use draw loosely because I'm using my tools. You actually have to draw it. Okay, so the first thing that I'm going to draw is my x. So, here we go, try that again. Make sure that I have the right colors here so you can actually see it. And you can't because, there we go. All right, so here's my x. Right, so here's my x, and I'm going to label it as such. So right here is my x. And if you want to, you can make it different colors. That might actually be helpful. So if you have the opportunity to do that, I would do that. Okay, and then the next thing that I am going to do is I'm going to make my squares. And I'm adding 7 squares to the x. Now typically, if you can't make it different colors, what you would do is you would make the lines dashed. Okay, so I am going to do this. really shouldn't be such a perfectionist when it comes to drawing my boxes, but it's really hard. I think some of you understand where I'm coming from with this. All right, so when you're drawing your boxes, you try to draw them with a dashed line or with different colors. So I'm adding 7 of them. So 1, 2, 3, 4, 5, 6. Now that should be 7. 1, 2, 3, 4, 5, 6, 7. Now notice my boxes, they're not perfect. It's okay. Life will go on. Okay, and again, I'm going to represent that those are 7 of them. And sometimes it makes it easier if I draw myself a little line like this to show that this is 7 and that it's all 7. So I've modeled that there are 7 of these and that there is a X amount of over here. And then all together, so now this is where I really need my little fancy tool. All together, if I put the 7 and the X all together, that will give me my 7 plus X. And there's my model. Fancy, right? Okay, so again, start with your variable. After you've done your variable, add your I shouldn't say add your constant, but place your constant, and then show how your expression comes into play. Okay? Now, for the next one, it's a little different because you have z and it's being divided by 3. So the difference here is that I have z as my whole thing. This whole thing right here is z. So I'm going to show that using my fancy little tool. And writing it in. And now I'm going to show that it's being divided into 3 pieces. And I'm going to do that with my dotted line again. So 1, 1, 2, 3. Now the tricky part here is since I want z divided by 3, I have to show that that's what I want in my answer. To show that that's what I want in my answer, I have to only pick that part for my variable. So z divided by 3, so even though right here, so I divided it by 3 in my picture, but then my answer, I would only want this one piece. Because after I divide it by 3, I only want this one piece. Right. So now it's your turn. You're going to go ahead and you're going to try to show me how you would do t minus 2 and then 4 times y. Give yourself a good think time, about 5 minutes. If you're struggling after 5 minutes, come on back and take a look at how we did it. Right? Always give it a good try, and if you can't do it, that's fine. I will tell you that for number 8, it's easier to start by drawing the variable and then thinking how, after I draw the variable, how many of those variables do I want? All right? When you come back, we'll check your answer. All right, so here for t minus 2, I started with t, and if I can find my little magic, there it is. So I started with t. So this whole thing here is actually t, And then I have 2 right here, and since I'm taking them away, what's left is the t minus 2. So this whole rectangle is t. I have these 2 that I'm taking away, so the rest of it from here to here is t minus 2, which would be my answer. For number 8, I have y. From here to here is y. I want 4 of them, so I split it into 4. 1, 2, and then that's all 4. And so from here to here would be 4 times y. Since this part right here is only y, that's why this whole thing is 4y. Whereas here, the whole thing was z, so this was z divided by 3. Right? Small part is y, big part is z. That's where the difference comes in. All right, example number 3. What we're going to do now is we're going to model some real world, or I'm sorry, we're going to compare expressions using models. Got a little ahead of myself. So Katrina, I want to say Katrina, but looks like there's an extra A in there. And Andrew started the day with the same amount of money. She spent $5 on lunch, and Andrew spent $3 on lunch, and then $2 on a snack after school. Do Katrina and Andrew have the same amount of money left? So we're going to write an algebraic expression to represent the money she has left, and then we're going to represent it with a model. So here's what happened. So she had X amount of dollars, and then she spent $5. So what she had left was this X minus 5 right here. So she started with X, she subtracted the 5, so this is what she had left. Okay, so her model would be X, or her expression would be X minus 5. Andrew also started with X amount of dollars. Okay, and then and we know that it's the same amount. That's really important to notice. And then he spent 3 and 2, so he spent and spent. So his expression will be X minus 3 minus 2. So now if you look here, they end up spending the same amount of money. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So even though they spent it in different ways, they ended up spending the same amount of money. So their models, even though their expressions look different, their models look exactly the same. So their models are equivalent. So we know they both have the same amount of money left. Right? And again, you can see that by counting up the fact that she spent $5, he spent 3, and then he spent another 2, and you can see visibly that their models are the same. All right, so now it's your turn. You're going to check out Tina, Julia, and Juan, and you're going to take a look at their scores on a math quiz, and you are going to see if they got the same grade on the quiz. And afterwards, you're going to think about how you know if they got the same score on the quiz or not. Okay, and then when you come back, we'll check your answer. All right, so for Tina, what you should have found is that her expression or her model would look something like this. There it is. Excuse me. All right, so Tina's model is that she had, so Julia's points are being represented by Y, and Tina earned 3 more points than Julia. So this whole rectangle is represented by Y plus 3. So Julia's points are Y plus 3 more. Okay? Then, if you look at Juan's model, the whole thing is y plus 2 plus 2, where Julia's is y, but then there's 2, and then there's 2 more. In looking at their models are not equivalent. So, no, they did not earn the same grade on the quiz. I know this because their models are not equivalent. And that's all we're looking for right now. We're not looking to dig any deeper into it. We're just looking at the models and saying, do their models look the same? Yes or no? No, they don't, so they're not equivalent. And yes, I understand that we can look at this and go, hey, 2 and 2 is 4, so this should be y plus 4. Agreed, and this would still be 4 boxes, but we're really focusing on how the model matches the problem. Okay? So you should have found that no, their models were not equivalent, so no, their grades were not the same. All right, so now we're going to model the real world situations. But when I say modeling the real world situation, we are actually going to model them in an expression. All right, so tickets to the water park cost $53 per person. We are going to write an expression to show the total cost for a group of people. So first and foremost, we need to figure out our variable. What is it? What does it represent? Okay, so in this case, do we know how many people are going? Because wouldn't that be what we need to know to figure out the total cost for a group? Since we don't know how many people are going, that is what our variable is going to be. So our variable represents how many people are going. And so I'm going to use P for people. So I know since it's $53 per person, and per is my operative word here, so 53 per person, I know that I'm going to do 53 times P. The best way to write this, though, is 53P. All right. Janice has some savings after babysitting. She adds $75 to her savings. How much has Janice saved? All right, so how much has Janice saved? She has some savings. So some is what we don't know. She adds, I'm sorry, I've got my thoughts backwards here. She has some savings. She adds 75 to her savings. So some. Some is what I don't know. So my variable represents how much Janice starts with in her savings. So I'm going to use S for savings. I know I'm very original. And so I know she starts with S savings. Adds is very plainly told to us here, and she's adding $75. All right, so now it's your turn. You are going to go ahead and do number 10 here, and when you come back, we'll check your answer. All right, so doing this, you are going to write an expression to represent how much money each niece receives. And you know that Helen divides, so that tells you right off the bat you're going to divide, and she wants it equally for her 4 nieces. If D represents the total amount, write the expression. The expression is D divided by 4. All right, that is it. So you guys are going to do your guided practice. Remember, you are doing it on GoMath. So go to GoMath, do your guided practice. These guided practice problems can be done for extra practice. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.